Hi, my name is Martin Moss. I'm the Regional Marketing Manager for North America. And I'm going to be doing an introduction into the Simple Switcher power modules from National Semiconductor. And what we're going to be doing today is an overview of that technology together in collaboration between National and Arrow.
And I'm Jennifer Cruz. I'm one of the field application engineers at Arrow Electronics. I'll be showing some key features of the new power modules and also be demonstrating some of their benefits.
So I'm going to be kicking this off with a brief introduction. So we begin now. And what I'm going to be doing is going through a very high-level overview of the Simple Switcher power module, the new family from National Semiconductor. So what you can see on this slide is a little bit of the market space for the technology that we have. And the X and Y graphs actually represent something. On the left-hand side, you have the output current, and on the bottom, you have the ease of use. So up until this new family was released, we had the controller family and the regulator family under the Simple Switcher brand. So really what this is about is a further extension of that Simple Switcher brand with the power modules. A little bit more about the ease of use. This gives you a little bit about the nomenclature, i.e. the part number. So what does the nomenclature mean? Well, LMZ means that it's actually a power module from National Semiconductor. So first of all, you have unique identification there. The A, as demonstrated by this slide, gives you that it's the first series or the first family to be released to market. It also gives you a hint that this is not going to be the only releases that National will be having in this area. The BB gives you the capability of the technology in terms of a VN capability. For instance, let's take the example here. LMZ1, first generation, 4203, means it's a 42 volt maximum VN capability. And as the 03 would say at the end of the part number, a free output capability. So the whole idea of this is actually the ease of use, making the part number easier for our customers to identify both before the design, but after design, exactly what the capability they've designed onto the PCB. Great use. This is the next one. This is actually a very brief overview of the first generation family. So the idea of this family is to make it very broad. And as you can see, the three families that we have supporting 24 volt, 12 volt, and 5 and 3.5 volt families, or the rails, I should say, gives a very broad overview for the market. Also, you can see many different types of variants of that, i.e. the current. 1, 2, 3, for instance. All of this is enabled with a combination of great packaging technology, and again, you'll see that later on, and how easy it is to use, but also great IC technology, the architecture that was used inside the package. So there are some challenges in using power modules today, and there's different types of technologies available. The first one is the open frame modules. Some of the challenges of this can be large size, in some cases non-encapsulation. Encapsulation can cause issues of robustness. An example of this could be that you can easily get dust on these PCBs or heat. That can cause issues of reliability. Also, they're not necessarily optimized for EMI. That can be a challenge in noise-sensitive circuits. The other type of module technology out there is the IC-like type of module. And these can be difficult to mount and difficult to rework. And again, a little bit of that we will demonstrate you today in terms of the work that Jennifer will show in her demo later on. Also, there's some heat dissipation challenges as well, and this could be down to the multiple different types of DAPs and also the thermal paths to the PCB. This is going to be a challenge for the power design engineer out there. So, just a wrap-up slide. What I'd like to do is demonstrate some of the national value advantages that we have. The ease of use of packaging. One solid pad on the bottom and the standard IC lead frame gives great advantages for the ease of use. Easy prototyping manufacturing, which we will demonstrate later on in a demo. Easy pin-to-pin compatibility for different load currents. Your current ranges may change or go up and down. Well, this will enable you to actually give you that capability of actually migrating from one version to another with no PCB design and ease of use. Great heat dissipation. Again, a great technology. The advancement of the packaging capability has given us that great industry-leading capability. Low EMI from the design of the PCB, from the design of the packaging, and from the design of the IC. All of this has been optimized for that feature. And again, fully wrapped in the software tool that we have inside of National Semiconductor called Webbench. So a little bit about not only this family, but also what's coming up. This family primarily is for less than 5 ampere technologies from 42 volts down to 5 volts. But we do plan to extend this even further. one of the first products that's going to come to market will be a 36-volt VIN capability and a 10 ampere capability. And this will be available in the February-March timeframe. We also plan to extend the voltage range up. And this will be available probably this summer in a June timeframe for you to actually begin to sample and develop into your designs if the first family doesn't meet your requirements. So what I'd like to do now is actually pass over to my colleague Jennifer Cruz, who's going to be demonstrating some of the key application advantages of this technology on the bench.